I had an interesting kind of personal challenge. I wanted to program like it was 1972. The way it used to be is people would purchase instruction manuals for a CPU, and then they would build using those instructions an interface of sorts, an operating system, and basically reading the manual and opening a notebook, a pen and paper, or pencil rather, and paper notebook, and then writing out the instructions for what instructions this CPU needs to run and where it needs to put things in memory in order to create an operating system, in order to make the computer do something useful. And rather famously, Steve Wozniak programmed or wrote a basic interpreter for the Apple, the first Apple computer, on a notebook. And he sat there and wrote everything out and said, I'm going to move this to that memory space, and then when this changes, that memory space is going to update, and then I'll move that flag over here, and then I'll test for that flag, and figured out the whole process. Read through his notebook, I'm sure many times to make sure everything fit together. And then when the time came to actually receive the CPU and the parts and to program the ROM for it, it ran first time, allegedly. So I kind of wanted a little bit of that experience. So I have my DigiRule 2U. I'm sorry, no, he ran it on an emulator. That's right. Or was it Microsoft? I don't know. It's not important. Anyways, I have a DigiRule 2U, which is a ruler with a replication of kind of a similar interface to the Altair 8800 or the PDP-11 70s computer, in that it's just bits you flip. It's binary data that you type in, and by type in I mean you literally flip switches or you press buttons to turn them on or off, and you program 1 0 1 1 0 1 1 0. Excuse me. And then when you get the byte of instruction, those ones and zeros, you decide where they need to be in the memory in order for your program to work. So I wanted to do a programming test, which is pretty common. It's deceptively simple. It's called a FizzBuzz test, and it's designed for interviews, programming interviews, see if people really actually understand what they're doing. But the idea is that it's simple enough that you should be able to sit down and do it with no reference, no internet connection, just no syntax, anything, helper, whatever. And I think it's a pretty good test, especially for someone who says they know the language. There's probably a few caveats I would give the test, but overall I think it's a good test. The idea is that you get an immediate feedback test of whether or not this person understands what they're doing, and you can kind of get an idea of how they structure their code. It's also something that should be completed in like 10 minutes maybe, depending on the programming language. But the idea is that you are intended to make a program which counts from 1 to 100, and whenever it's going to count, it's going to display the numbers 1 to 100, and whenever it is displaying a number which is divisible by 3, it will, instead of the number, say fizz, and whenever it displays a number which is divisible by 5, instead of the number, it will display buzz. And if it finds a number which is divisible by both 3 and 5, then it will say FizzBuzz. Otherwise, it just prints the number. So it's a pretty simple test, and I wanted to do it in assembly. on the DigiRule like it's the 70s. And the DigiRule has a pretty solid suite of software for making it easier to program it. It's assemblers and compilers and programmers and stuff like that, designed to make it easier to use the DigiRule 2U. But I didn't want to do that, so I just got I did the notebook thing. I read the documentation. I wrote out what the instructions should be, which is, in assembler, you're using, like, you want to do a jump command, so you write JMP, or you can write jump. It doesn't matter, as long as you understand what the code is that you're referring to. You write the jump command, and then you write what memory space it's supposed to be jumping to. And you build your program like that, line by line. And I did it on a digital notebook. I did it on OneNote so that it was easier to grab giant blocks of code and move them down so that I could squeeze one line in real quick. You don't have to erase everything or play cut and paste with actual physical paper. But that was the point, to not use those additional tools, to just write it freehand, handwritten programming. So I got everything handwritten out for the instructions that I thought would make FizzBuzz, and wrote everything out. I planned it out, I guess you could say. Wrote it out. Took all of the instructions. You know, the instruction codes like jump code or increment register code, increment RAM code, and translated that into the actual machine code, which is the hex or the binary values, the hex values. And then I translated that into binary, and I typed it in on the ruler. 1, 1, and 1, 0 at a time. I'll fill out 1, 1, 1, 0, 0, 1, 1, 0, 1. Enter. Next instruction. 1, 1, 1, 0, 0, 0, 1, 1. Enter. Next instruction. And did that for 124, technically 129 instructions, and ran it. And there were 3 bugs. 2 were typos, and 1 was an instruction that I missed, but it was easy enough to move things around and get it in. But there it was. I did FizzBuzz in the I did a FizzBuzz in the 70s. And the idea that people could have these old Altair 8800 or PDP-11 computers, and they were sitting there with a notepad and a pencil and an eraser, hopefully a big eraser, and saying, all right, here's what we're going to do. We're going to write us some instructions. We're going to program a computer. Here's what it's going to need to do. How do I need to use the CPU instructions and manage the memory in order to make the computer do that? Also, what is the output going to be? In the case of the DigiRule 2U, I wanted the output to be a terminal output, because I love my serial terminals. And I wanted it to print it on the screen rather than give me an LED display where it counts up the numbers in binary, and then every time there's a fizz, it doesn't show the numbers, but then shows one of the LEDs on the top that indicates fizz. You know, you can label it fizz if you want, and then continues counting on the bottom, and when it gets to a buzz, it'll light up the other LED, and then a fizz buzz, it'll light up both. So I still might do that just for fun, I guess. I don't know. I'm not sure why this is fun, but it is, and I liked doing it. It was an interesting exercise. I wouldn't recommend it though. No, I might. It's important to understand how many layers of abstraction you're dealing with, when at the root of things it's just a CPU. It's just ones and zeros running around a silicone, some bus lines of silicone. I don't know.